IOE 413, Introduction, Study Guide. This question is about the hospital case mix problem. It asks you to formulate a model whose overall goal is to determine the case mix of a hospital so as to maximize profit. This is a trivially small hospital. It only has one operating room that operates 9.5 hours a day, 5 days a week, 52 weeks per year. It only has 6 beds, but they're open 365 days per year. I won't go over all the other data that's provided in the table in the study guide. We'll refer back to that as we go and formulate this problem. What we need to do is determine the constraints, decision variables, and objective function, and non-negativity restrictions for this problem that will lead to a linear program. Let's begin with decision variables. We're going to have two. We're going to have x1 and x2. x1 is going to be the number of what are called primary total knee arthroplasties. That's TKAs per year. So a TKA is a total knee replacement, total knee arthroplasty, that's why it's TKA, but it's a total knee replacement. Primary means it's the first time that it's done. The patient has arthritis and a surgery is done to put in a prosthetic knee. Now, a revision would be if that prosthetic knee had to be redone in a second surgery, but this is the first surgery for the knee replacement for the patient. That's why it's called primary. Now, x sub 2 is the number, again, of primary, but this time it's THAs, which stands for total hip arthroplasty or total hip replacement. And this is again per year. So x1 is the number of primary total knee arthroplasties per year performed in this hospital, and x sub 2 is the number of primary total hip arthroplasties performed per year in the hospital. All the analyses in this model are going to be done on an annual basis per year. Let's consider the question of bed capacity in the hospital. The way to think about this is in terms of bed days. That is the number of days times beds that are available over the whole course of the year and how many are used. So as an example, let us go back and go from the basic input data for this question provided in the study guide, that one patient undergoing a total knee replacement is going to be in the hospital 2 days. That's just a given in this problem, okay? And a total hip THA patient, okay, is going to be in the hospital 4 days. Again, just from the statement of this problem. The number of bed days that will be used by the knee patients will be 2 times x1, and the number of days used by the hip patients will be 4x2. So the total number of days, or bed days I should say, used by these patients combined is 2x1 plus 4x2. And that is what is actually used by the patients. And that needs to be compared to an upper bound on the number of bed days available over the course of the year. So what should we use as an upper limit on bed capacity? Well, we're doing this on an annualized basis, remember? And we said the hospital has 6 beds. And the hospital is open 365 days per year. Okay, so that's days per year. Multiplying that out gives us 2190. And the units here would be bed days, bed hyphen days per year. Remember, this is important because we're doing this on an annualized basis per year. So if we look at the number of bed days utilized per year is 2x1 plus 4x2, and the limit is 2190, and what's utilized has to be less than or equal to what's available, so we put a less than or equal to sign here, and that is our bed capacity constraint. And just note that it's on an annualized basis, so we're doing this per year, and all the units here really are bed days, and this is done on an annual basis per year. So let's consider the second constraint on OR time. Okay? From the study guide, we know that the average time for a knee, a TKA, is 160 minutes. That's 160 minutes per TKA case. For hips, THAs, it's 185 minutes per case on average. So the amount of time per year that's required in the OR, expressed in terms of minutes, is 160 x1 plus 185 x2, right? So x1 and x2 are the number of knee and hip cases respectively done per year. So when you multiply the time per case by the number per year, you get the total time per year expressed in minutes. Now let's look to see what the total operating time availability is per year so we can set up the full constraint. So the amount of operating room time available every year, okay, is 52 weeks per year times 5 days per week times 9.5 hours per day. I said that at the opening here, that this operating room was open 9.5 hours a day. And then there are 60 minutes per hour. Okay, and when you multiply that out, you get 148,200 minutes per year. We're doing this on an annualized basis. That's why we want to get it per year, which means that when we write this down, you get 160 x1 plus 185 x2 is less than or equal to 148,200. And this is all expressed in terms of minutes and is on an annual basis, that is per year. So this is our second constraint to the linear program. 160x1 plus 185x2 is less than or equal to 148,200. Now let's do the objective function. You'll recall from the statement in the study guide that for a total hip arthroplasty, the margin or the profit was $12,000 per case. And the total knee arthroplasty, the TKA margin, was $8,000 per case. That means that the total profit margin we want to maximize, Z, is equal to 8,000 x1 plus 12,000 x2. That's our objective function. Now let's put this together as one linear program. We start with the objective function, which is maximizing the annual margin for the hospital, which is 8,000 x1 plus 12,000 x2, such that, and now we have our bed constraint, 2x1 plus 4x2 is less than or equal to 2190. And our operating room time constraint of 160 x1 plus 185 x2 is less than or equal to 148 200. And now we have sign restrictions on x1 and x2 being non-negative because you can't do a negative number of hip and knee cases. It has to be 0 or more. In fact, we could put an integrality constraint on this to make an integer program. However, we're not going to because the problem said that we wanted to formulate a linear program. So this is an LP for our case mix model.